Welcome to aminacademy.com. In strength of material regarding shear force and bending moment for cantilevers, let us solve the problem. A cantilever of beam length 2.5 meter carries the point load as shown in figure. Draw SF and BM diagram for the cantilever beam. Here the cantilever beam figure is given and point loads are noted here. We have to draw shear force and bending moment for this cantilever. Now first shear force. Shear force diagram. At D. At point D, shear force FD equal 1000 Newton, positive 1000 Newton. At C, FC equal shear force at C equal 1000 plus 800, that is equal 1800 Newton. At B, then shear force 1800 plus 400 equal 2200 Newton. At A is FA, shear force FA equal same 2200 Newton. There is no load on point A, therefore the same shear force like here. Now let us draw the shear force diagram for this information. We have to draw first line, baseline up to this point. Now this is a point D. Point C, point B is a point A. Now at point D, is shear force is 1000 Newton. For 1000 Newton we will do some scales. Suppose let it be this 1000. Now from this we have to draw a horizontal line up to this much. Now let it be this is 1000 Newton. From this 1000 Newton you have to draw a vertical line for 800. This is 800 Newton. From this 800, then from this 800 you have to draw 400. Then join them. This is a 400 Newton. Now we can shade this one. It's a positive thing. This is a shear force diagram. Now let us do bending moment diagram. for bending moment diagram. BM at point D. Suppose let it be here first. This is D dash. This is C dash. This is B dash. This is A dash. Now bending moment BM at D, the point D equals 0 because there is no length extended up to D. This the point D BM is D 0. Then BM from C to D, BM from C to D is that you can put it MC is that is MC equal minus 1000 x, which is equal minus 1000 into 1.2 minus 1200 Newton. Then next BM from B to C. B to C is that is MC equal minus 1000 x minus 800 that is total is 1.2, 0.9 is 2.1 minus x minus 0.9. Here now we'll keep here x is minus 1000 and x is 2.1 because the addition of here you can write x equal 1.2 plus 0.9, 1.2 plus 0.9, which is equal 2.1. So 1000 into 2.1 minus 800 into 2.1 minus 0.9. So which is equal minus 2100 minus 800, 2.1, 2.1.9 is 1.2, that is 800 1.2, so which is equal minus 2100 minus 960, which is equal addition 0 6 0 3 30 2100 is 0, that is 0 plus 0 0 6 and 10, okay, 3060 Newton meter. Newton meter here. Now next is between A to BM, between A to B. Now BM is between A to B is, now we have to calculate from point D, then which is equal that is we can write MB then which is equal minus 1000 into 2.5 whole length minus 800 into 2.5 minus 1.2 minus 400 2.5 minus addition of point that means 1.2 0.9 is 2.1. So we have minus 1000 into 2.5 is minus 2500 minus 1040 that is 2.5 2.5 minus 1.2 into 800 is 1040. Next 400 into 2.5 minus 2.1 is minus 160. So which is equal minus 3700 Newton meter. Now we'll let us write BM at different points. BM at different points. We'll write MD, that is bending moment at D equals 0. Bending moment at C is minus 1200 Newton meter. BM at B is 3000 3060 3060 and MA is minus 3700, all minus. Here we have to put these points here. Now we'll draw the baseline. Our first one minus 1200. So let us write the point. Let's suppose this much is for some scale, it is 1200 minus 1200. Next is minus 3600. Here BM at D0, this is for suppose this 3000 1200 it is. We'll keep here a little bit here this 1200, this is 3060 3060 and next last is 3700. Like we'll join is a bending moment diagram for shading this. Let this one negative. So we have to note the points. This point at this is bending moment at is 0. This minus 1200. Next is 3060 minus 3000 minus 3060 and 3700 minus 3700. This is a shear force diagram. Now we'll put the points. This is point D, this is a point C, so point B, point A. This is a common baseline. Here, this is a baseline for shear force and this is the baseline for bending moment. We have done. Please subscribe our YouTube channel.